Okay, so we are starting the first lesson in chapter 3, which is simplifying exponential expressions. The key to simplifying these expressions is to recognize, what's a base, and what the exponent is, and realizing that actually everything has, has an exponent. Even if there's not a number there, it's one. And also you need to expand them and then bring them back. So we're going to be simplifying expressions with exponents. The main thing to remember is that writing exponents are repeated multiplication. So all of the things that all of the expressions we're looking at deal with multiplying different terms together. So an exponent is shorthand for repeated multiplication. For example, n to the fourth power is the same as n times n times n times n. So there is no adding going on. It's repeated multiplication. So in this section, think about multiplication. There's no adding, there's no subtracting. When we get to some of the rules they involve, that's where there's some confusion. There's never a confusion if you're able to expand things and then simplify them. B to the a power, where b is the base and a is known as the exponent or to the power. For the term y to the seventh power, y would be the base, 7 would be the exponent. When we get to this one now, actually technically 4 is a base, the power would be 1. X is a base and it's to the fifth power. 4x is not a base because it's not taken to the same exponent. So 4 would have a different exponent than x. This term where we have x to the third power to the second power, there's actually a couple bases. X is a base, being taken to the third power, as well as x to the third power is a base, which is being taken to the second power. Okay, so every exponent has a base to it. You have to determine what the base is. When we get to this one, in order to simplify, the best thing to do is to expand them and then bring them back together, group them all together. So where I see kids making mistakes is if you're not expanding it. So when I look at 6, even though there's not multiplication signs between these, we can infer that there's multiplication signs between everything. So we have to get out of that term. This is not 6 x squared tiles. I mean, technically it is, but this is really, we're thinking of this as multiplication. So writing this part right here is going to be 6 times x times, and then 6x to the third is 6 times x times x times x times y to the fourth, y. Okay, so spreading it all the way out, showing that expansion of these exponents. Then I'm going to regroup them. I'm going to put the 6's together because those are like bases. And then I'm going to put the x's together because those are like bases, and the y's. Now, once I have the bases together, I can re-simplify them. So 6 times 6 is the same as 6 squared. X times x times x times x times x is the same as x to the fifth. And y times y times y times y is y to the fourth. So technically this is mostly simplified, but I can figure out what 6 squared is. It's 36. So the most simplified version of this one is that 36. It's 36 times x to the fifth times y to the fourth. So now when there's an exponent on the outside, I start with the parentheses. This is really 2 times d times 3 times d times d, because the thing that's being squared is this d. So, but then this also says I need 2 of them. So I'm going to make another one of them. So 2 times d times 3 times d times d. Now the parentheses again is a separator, but it's just multiplication. So I'm going to group my numbers together, 2 times 2 times 3 times 3. And then I had 3 d's in this parentheses and 3 d's in that parentheses. So when I rewrite it, it's 2 squared, 3 squared, d to the sixth, all being multiplied. 2 squared is 4, 3 squared is 9, d to the sixth is d to the sixth. This becomes 36d to the sixth power. I've done a couple more examples on this next page. I've been expanding them and then regrouping them. A way to write exponents is to use this little v here. And that comes from Shift 6.